Today we're going to be going over an introduction to exponents. We have a couple of examples that we're going to work through together here, so let's get started. For question number 1, we have 2 to the power of 5. Or another way that we could say this is that we have 2 to the 5th power. But before we solve this, let's go ahead and break this apart because we can see that we have two numbers here that are totally different sizes. Well, the first of these two numbers, the larger of these two numbers, which in this case is a 2, that's going to be known as our base. And then the smaller of these two numbers, which in this case is a 5, well, that's going to be our exponent. And I'm sure you're wondering, what exactly is the difference between the base and the exponent? Well, the base tells us the number that is being multiplied by itself, and the exponent, as we can see up top highlighted in yellow, tells us how many times that base is going to be multiplied by itself. So when we have 2 to the power of 5, that tells us that we're going to be multiplying our base of 2 by itself 5 times. So let's go ahead and write that out in expanded form. We have 2 times 2 times 2 times 2, and lastly times 2. So as we can see, we're going to be multiplying our base of 2 by itself 5 times. And as we can see when we write this out in expanded form, it takes up quite a bit of time and space. So we write numbers in exponential form as a way to abbreviate when a number is multiplied by itself over and over again. Because we can imagine if we had 2 to the power of 15, how much time and energy that's going to take to write that out when it makes more sense to just write 2 to the power of 15. Now let's actually work through and solve this. So let's start out by multiplying 2 times 2. We know that that gives us 4, and then we're going to multiply 4 times 2. Well, we know that that's going to give us 8, and then we're going to drop down the other times 2 that we have left. So we have times 2 and times 2. Well, when we multiply 8 times 2, we get 16, and then we're going to drop down our last remaining times 2. And when we multiply 16 times 2, we get 32. So when we have 2 to the power of 5, we get the answer of 32. Now moving on to question number 2, where this time we have 11 to the power of 2. But something special happens when we have an exponent that has a value of 2. It has a special name. And any time that we have an exponent that has a value of 2, we can say that it's squared. So here we have 11 squared. So since we have 11 squared, we know that we're going to be multiplying our base of 11 by itself twice. So we have 11 times 11. Well, we know that when we multiply 11 times 11, we get 121. So when we have 11 squared, it's going to give us the answer of 121. Now moving on to question number 3, where this time we have 6 to the power of 3. And just like with our 2 earlier being squared, anytime that we have an exponent that has a value of 3, we can call that cubed. So here we have 6 cubed. So let's go ahead and write this out. We have 6 times 6 times 6. And we know that when we multiply 6 times 6, we get 36, and then we're going to drop down that remaining times 6. And when we multiply 36 times 6, we get 216. So when we have 6 cubed, we get the answer of 216. Now moving on to question number 4, where this time we have 3 to the power of 4. So since we have an exponent of 4 here, that tells us that we're going to be multiplying our base of 3 by itself 4 times. So let's go ahead and write this out in expanded form. We have 3 times 3 times 3, and lastly times 3. So starting to solve this, when we multiply 3 times 3, we get 9, and then we're going to drop down our remaining times 3's. And then when we multiply 9 times 3, we get 27, and then we still have to multiply that 27 by 3. And when we multiply 27 by 3, we get 81. So when we have 3 to the power of 4, that's going to give us the answer of 81. So hopefully by now you feel a bit more confident working with exponents. Help make math less complicated by smashing those like and subscribe buttons. As always, enjoy today's math journey.